The HMS Sasquatch leaves port on a bearing of north 23 degrees east. So remember, with bearings, we measure off from north, we swing around to the east by 23 degrees. And it said it travels that way for 5 miles, and then it changes course and follows a heading of south 41 degrees east. So we draw a line and measure off from south. We swing around to the east by 41 degrees. And it travels along there for 2 miles. How far is it from port? That should say from. Okay, so here it is. How far is it back to the port here? So let's call that X. Okay, as we're looking to see what we have and what we need to know, we want to find the side of this triangle, and we have two sides, 5 and 2, but we don't have an angle between them. So we don't have an angle in the triangle, but we've got some angles in here, so let's see if we can work with what we've got to get angles in the triangle. So anytime you have parallel lines, which when you have bearings you're going to have parallel lines because you're measured off north and south and they're parallel to each other, and you have a line that cuts across them, I call that a transversal. But this angle is the same size as this angle. If you're thinking of the lingo from geometry, it said two parallel lines cut by a transversal. The alternate interior angles are congruent. So on alternate sides or opposite sides of that, and in between the two lines, those angles are the same size. So using that idea, let's look at this north-south line and this north-south line, and we have this transversal, this line going across, and this is 23 degrees, so this angle right here is also 23 degrees. Well, that helps us because we now have an angle in the triangle. This whole angle is going to be 23 plus 41, which is 64 degrees. So we now have an angle in the triangle and two sides. We don't have an angle side opposite a pair to use the law of sines, but we do have the three pieces we need to use the law of cosines. So that's what we're going to do. So the x squared equals the sum of the squares of the other two sides, so 5 squared plus 2 squared minus 2 times the product of those two sides, 5 times 2, times the cosine of the angle between those two sides, and that was the 64. Well, we know that doesn't look like a squared there. We know everything. That's just a matter of put that in the calculator then, but I'm going to go ahead and square root both sides when I do so that I will have x. So put that in the calculator, and rounded to 1 decimal place, it looks like I get 4. Oh, it says to round to the nearest hundredth. Although it says to the nearest hundredth, I get 4.498. So that 8 makes the 9 go up 1, which makes it, so it's going to be 4.5. Okay, and this is miles. So that's the distance back to port. There's another question here. It says, what is the bearing to port? Round your angle to the nearest degree. So the bearing to port would be what this would have to travel to follow that side x from that last place where we are. So it looks like it's going to be south swinging around to the west. So it's going to be a south, some angle, and west, because I'm just looking at the picture here to see what we've got to do from here. So if I'm looking to see how to find this angle, if I looked at these parallel lines and see this angle, it would be the same side as an angle over here on the left part of the triangle. I'm marking it here in green. Well, I know a piece of that angle is 23. If I found the rest of that angle by finding that angle in the triangle, then I could add those together, and that would be the same size as my bearing angle because it's on opposite sides of that line that cuts across and goes to those two parallel lines. So let's work on finding that angle. So I can do that with the law of sines. Let's just call it theta. So we've got sine theta over 2 equals, let's do our angle and side opposite at pair, sine 64 over 4.5. So we can multiply this 2 to the other side, and then we're going to need to do inverse sine to find the theta. And it says round theta to the nearest degree. So I'm going to do inverse sine of 2 sine 64 divided by 4.5. And it looks like I get 23.54 degrees. So if I add the 23.54 to the 23 up here so I can get this whole angle, I will have my bearing angle here. And if I round to the nearest degree, that would be, it looks like that would be 46.5, so it's got to go up to 47 degrees. So this is the bearing to go back to port.